now that we have an understanding about how to deal with linear functions abstractly, we're going to start using them in applications. So we're going to look at applying linear functions in different contexts. So the first thing we're going to do is we're going to introduce point-slope form for linear functions. That'll make it a little easier to find the formulas for linear functions. Then we're going to find a formula for a linear function model in an applied problem, and we're going to use that to interpret the slope in the applied problem and make predictions based upon that model. All right, so right now I'm just going to summarize the techniques we've been using to find formulas for linear functions. So our general situation is we have a line, a linear function with slope m and a point a comma b on the graph. So the question is, what is a formula for the linear function? In this case, I'll call it L. So we can think of a general point on the line as being x for our x coordinate, and L of x, that's our output, so that's our y coordinate. And so the question is, what is the slope? Well, we actually have 2 points. We have two ways of looking at what the slope is. First of all, we're given in the problem that the slope is m. So that's one way of thinking about what the slope is. On the other hand, we have 2 points, x comma L of x and a comma b, and we can use the average rate of change formula to find the slope between those 2 points. So there we subtract our outputs, L of x and b, we subtract our inputs, x and a, and then we divide those two. Now, since both of those represent the exact same slope, that must mean they are equal to one another. So L of x minus b is divided by x minus a is equal to m. And then it's just a matter of solving for L of x. So we can multiply both sides by x minus a. That's going to cancel out the denominator x minus a on the left-hand side, so we get L of x minus b. And on the right-hand side, we get m times x minus a. Now, if we add b to both sides, solving for L of x, we end up with L of x equals m times x minus a plus b. And that is what is called our point-slope form. And what is really nice about the point-slope form is if you know the point and you know the slope, you can just plop those numbers into the formula, and that gives you the formula for your L of x. So whatever your slope is, you put that in for m. Whatever the x-coordinate of your point is, you put that in for a. And whatever the y-coordinate of your point is, you put that in for b. So let's go ahead and use that on a particular applied problem. So let's suppose we have a large container with water in it. We don't know how much water there is in the beginning, but we do know that we are going to pump in additional water at a constant rate, which means the rate of change of the amount of water in the container is going to be constant. That gives us a linear function. So you measure the water level after 1 minute, and you have 30 gallons of water in the container. After 2 minutes, there are 40 gallons. And again, you don't know how much water there was at the beginning, but you do know how much water was in there at those 2 points, and you know the water was put in at a constant rate. So now we let A of t be the amount of water in the container at time t, and we are going to look for a formula for A of t. All right, so first of all, there's nothing in this problem that directly tells us what the average rate of change is, what the slope of our line is going to be. However, we do have 2 points, and we can use those to find that average rate of change. So we know we have at time equals 1, there are 30 gallons, so we have the point 130. We know that at time equals 2, there are 40 gallons, so we have the point 240. And we can use those 2 points to find the slope of our line. So for the slope, we're going to take our 2 outputs, 30 and 40. We're going to subtract those, 40 minus 30. And then we're going to subtract our two x coordinates, or t coordinates, if you want to think of t as time. That's 2 minus 1. And when we solve those, we get 10 for the slope. Now we can put this into our formula for point-slope form. So remember, as long as we know the point and the slope, we can just put in the numbers. So we get 10 gallons per minute for our slope. So our A of t is going to be equal to, well, remember, it was m times x minus a being the x-coordinate, plus b, which is b is the y-coordinate. And in this case, instead of x, since our input variable is t, we're going to use t in place of x. So, of course, the first thing we're going to do is put in our slope, that's 10. And then our next one is going to be, well, in the old days it was x minus our x-coordinate, but since t is our input variable, it's going to be t minus our t-coordinate. Now we have 2 points to choose from, and we can use either one. If we use the first one, t equals 1, and then a of t equals 30, we're going to get t minus 1. And then since 30 is our y-coordinate, we're going to get plus 30. That's what our point-slope form tells us. And then if we multiply that 10 through, we get 10t minus 10, and then plus 30. And then if we simplify that, we get 10t plus 20. And you may wonder, do we get the same thing if we use the other point, the t equals 2, and then the a of t equals 40? Well, if we use 240, we get, instead of 10 times t minus 1, since our t-coordinate is 2, we get 10 times t minus 2. And instead of plus 30, since our y-coordinate is 40, we get plus 40. When we multiply the 10 through, we get 10t minus 20 this time, plus 40. And when we do minus 20 plus 40, that gives us a plus 20 again. In both cases, we get the exact same formula. Now that we have a nice model for how much water is in the container at a given time, we can start asking questions like, how much water would we predict will be in the container after 5 minutes? Well, in that case, all we're saying is 5 minutes means that t equals 5. And so if we find a of 5, we're just going to put 5 in for t. 10t plus 20 becomes 10 times 5 plus 20. 10 plus 5 is 50, plus 20 is 70, so we get 70 gallons. Now we can also ask predictive questions like about time, not just about how much water is in the container. For instance, if we want to have 100 gallons in the container, we might wonder how much time is it going to take to get there. Well, this is going to be a little bit more indirect. We know that we want for a of t to be equal to 100. A of t is the amount of water. 100 gallons is the amount of water that we want. So we want a of t to equal 100. Well, we have a nice formula for a of t. A of t is equal to 10t plus 20, which means that we want 10t plus 20 to equal 100 as well. And now it's just a matter of solving for t. If we subtract 20 from both sides, we get 10t equals 80. If we divide both sides by 10, we get t equals 8 minutes. And that tells us that if we leave the water on for 8 minutes, we'll end up with 100 gallons in the container. So now I think you're ready for the activities. The name of the activities is Applying Linear Functions, and as usual, it's a PDF file that's included with this video.